we're going to talk about a line today. What we're going to do is we're going to define what a line is, because some people had problems with that. Okay, and so let's make sure we all are on the same page today, after today, and we know what a line is. So how did we start? Well, we started the other day, and we talked about, not the other day, we talked already 3 or 4 sessions now on the universal movie. Okay, and here it is. Go on the other side. Give me a second here. Here it goes. Okay, we talked the other day about this, the universal movie, and we said it's a tool. It's a tool we use, what? To identify objects, one, to define static concepts, and to differentiate them, static from dynamic concepts. And among the static concepts, we have direction. Okay, direction is a static concept. Some people believe direction is a dynamic concept, something that's moving or something. Okay, so that's where we started. Okay, let's just go with this. And then I had to define direction, and this is the path I took in reasoning. Okay, I said, well, these are things that you require to define direction, or apparently this is what you do need. Okay, you need 2 objects, which automatically makes it a concept, because the word concept is defined as a word that includes or embodies 2 objects. Okay, so that part's taken care of. We need 2 objects. They need to be facing, and one object, no matter how it's facing, one face always faces another object. Okay, 2 objects have distance between them. It's got to be between 2 surfaces. Aiming, it has to be straight, and it has to be made of a single piece. You cannot chop direction into pieces. Direction is made of a single piece, or what you can say is continuous. Okay, so what are the conclusions? Well, it's a static concept. It's qualitative, okay, meaning it doesn't belong to math. Continuous, made of a single piece, straight, distance with an arrow. That's what essentially what direction is. Requires 2 objects facing, and you can't have direction between concepts. Okay, so you really cannot have direction between locations. Okay, so those are the definitions I came up with. The 2 ones that I favored was the first and the second one in darker red, line between 2 objects and straight edge. And then on the bottom, 2 lesser ones, mutual facing of 2 objects and line of sight. Okay, that's where I ended up the other day. And some people had questions. So I'll go with the first fellow who had an interesting question. He said, how does one look at a frame and know the direction of the object's points? Having trouble picturing direction as static. And he does have a point. Here we have 2 points, 2 things, 2 balls. And just by looking at that, would you know what direction is? Okay, could you conceptualize direction with just those 2 points? Okay, if you put a line there, which direction is it flowing, etc. There's some questions there. So we thought that was a good question that he put up there. Okay, he's got a valid concern. Here's another fellow. He did a little better, and he said, "Static concept, but straight. That doesn't seem right." You're absolutely right. And unfortunately, I hate him because it means I got to buy him a beer when he comes to Germany. Okay, that doesn't seem right. He's right. Okay, should straight only apply to objects in scientific English? Yes, absolutely. Is the rope model, rope lies between all atoms as they should seemingly have something to do with direction, and they are straight, aimed at other objects, are continuous. Your first definition there, line between 2 objects, is just describing the rope, right? How about direction? The orientation of the rope between any 2 objects, okay, which seems to mesh with distance, the length of the rope between any 2 objects. Okay, he said a mouthful there. The first thing we need to clarify is that under the rope model, okay, we say that any 2 atoms are bound by a rope. Okay, so there's the model. 2 atoms, my fist, and bound by a rope. That's the model. That's a basic model. Okay, so we usually talk about distance as being between 2 atoms, or any atoms, or things, made out of atoms. We never talk about distance between energies or fields, okay, because those do not have shape. Okay, so we have 2 atoms, and we say, okay, this object made of this atom is different than the object made of this atom. And so we don't see the rope. What we see is this, right? And we say, okay, what we have is separation, distance. And under that, yeah, we can say that the rope is equal to distance because the separation between 2 atoms is the rope, the length of the rope between them. Okay? But that doesn't cover the distance between 2 ropes. And that's another concept. It's like saying the distance between 2 energies. Okay, because that's what the rope is considered under quantum. It's considered just a ghost called energy, which is what comes out of the atom, and they call that energy, that light, that electromagnetic wave or field or whatever they want to call it. And they call all these, they have all these concepts for that because all they did is measure and give them names. You know, they gave them units and numbers. Okay, so not always is distance equal to the rope. Just want to clarify that. But then, you know, we still have a problem because these people asked good questions, okay, and it put Hans and myself to work overtime. We spent over an hour discussing this, and I'm not sure we figured it out. I'm just going to do my best here today, so please don't embarrass me too much. Okay, I'll do that. I'll do that myself, please. Okay, so here it is. Okay, let's start slowly. Here we have distance. Okay, we have two objects in our universal movie. And we have that that stick there, that white stick, and we call that distance. But actually, we put that stick in there by force. It shouldn't be there. In other words, you should not confuse the stick, which is an object, with a concept called distance, which is what this fellow was referring to. Okay, this is what it should look like. This is what you see. Okay, we put this in there with our minds, or sometimes even drawing on the board, right? But this is what's out there. Okay, so let's just make sure that we understand that part, that we do not need the stick to conceptualize distance. We tend to replace distance, the concept, we reify it and put a stick in there and call that line, we call that distance. Okay, so let's make sure we understood that part first. Okay, this is a little tricky because this is a very hard word to define, no doubt about it. Okay, and so here, let me show you something else. Here we have distance and also direction. I want to show you that they are not dynamic concepts, either one, distance or direction, okay? So we have distance, and what happens is the mathematicians, they do not use the distance at the top. The stick is separate, which represents separation, again, reification. What they do, they have distance traveled, which is you see on the bottom one there for the distance, okay? And if they're going to do that, what we recommend is that they reify it, but then they should put a line made of dots or dashes so that we know that they're talking about locations or movement. The solid stick simply illustrates that it's a single, it replaces just the distance, the separation, okay? And the same thing with direction. Direction, you would think, all we need is just to put an arrow at the end of distance, okay? And direction is not a dynamic concept, so if you're going to represent direction with a dynamic concept, you should use a dotted or dashed line. And again, we're saying that's wrong. Okay, it's not what direction is. Direction is a static concept. Therefore, if you're going to reify it, if you're going to use an object to represent a concept, at least use the stick, okay, the solid stick, and not the dashed lines. And conversely, for those who think it's dynamic, at least be honest and put, you know, the dotted or dashed line. That's what we recommend for any reification of lines, okay? Either you talk about many locations, numbers, whatever you want to call them, or you talk about a single separation, okay? And if we illustrate them differently, at least we don't get lost in the concept that it's either static or dynamic, okay? Let's keep the illustrations right. Okay, so here we have the question this fellow asked. He said, look, we have two dots there. Please tell me which way that thing is pointing, or what direction do we have there? And so it's a valid question. Okay, so let's see if we can answer some of these questions. And again, all I'm going to do today is really embarrass myself, okay? But we'll do our best we can here. Okay, let's start with our universal movie, okay? Here we have the universal movie, okay? And we're going to build upon this. First, we're going to put two objects there, okay? We have two objects or two locations, you could say, okay? Remember, the object is different than the location. Location has to do with the set of distances between those two objects, okay? Okay, so now we are going to conceptualize distance, okay? So what we do is we typically put a stick between them, but remember, the real distance is this one there, okay, where there's nothing between them. And what we do is we put a stick just to represent the fact that we have a separation. We'd like to put a solid stick so that we know it's not traveling, it's not a bunch of locations. What we have is simply separation from one surface to the other. Okay, so far so good? Okay, so now what's the issue? The issue is that when you are looking at direction, okay, you could say, like I said the other day, that direction is distance with an arrow at the end of it. Okay, and so here we have, you know, the same distance, but now we're going to put an arrow. We're not going to ask what the arrow means or anything like that. We'll just say, look, it's distance with an arrow. Solid stick, right? We're going to put an engine arrow at the end of it. Okay? And so we say that's how we illustrate direction. But even this is wrong. There's something wrong here. And let's go with what's wrong with it. Okay? And that's where I was misled the other day by myself. Okay? Okay, here's the problem, the first problem. First problem is that you don't need a second object. When you have a second object, it answers the question this fellow asked, and that is, how do we know what direction? And we're not trying to find out what direction, which direction. We're trying to define the word direction. So when you put a second object there, when you put two objects, two balls or whatever, you're talking about a specific direction, okay? And we don't need that because direction is indefinite. It extends forever, okay, in that sense, okay? So you don't need to put a second object to conceptualize direction. In fact, remember, all these things are from the observer's point of view. The observer is looking at a frame, okay, of the universal movie and inventing concepts that he gets out of the picture. The picture only shows you what you see there in the second frame, just a bunch of little dots, okay? And in this case, you see one red ball, and you see the line that we put in there, right? But all you have in real life out there in the universe are just atoms. That's all you have, okay? It's we, the observer, who suddenly, because we have such a sophisticated mind, we put in their concept, we invent concepts. We see more than what is there. We have this subjectivity, and we say, look, we have here a ball, and we have direction, which is indefinite, just a line there that we put to reify direction, but we don't need a second ball. We don't need a specific direction. We just want to define the word direction. And what we do, we are going to replace, in fact, the first object as well. What are we going to replace it with? Well, the observer is going to put his eye where the ball is, okay? That's direction there. Direction means that when you look at something, whether it's distance or existence or in anything, or any static concept inside the universal movie, universal frame, just one frame, the frame just shows you one thing. What you come up with in your mind is something you're inventing, it's subjectivity, okay? And in this case, what you're seeing is that we have to put the eye where the first ball was, and what you have is line of direction, line of sight, okay? Line of sight, that's what my final conclusion is until now, until someone can come up with a better definition of direction, okay? So I'm saying that direction is simply line of sight. And by line, I don't mean the line of geometry. Line of sight is simply a synonym of direction, is what you're staring at. So we're not saying that there's a line that you're going to put a line in there, even though you could say that it's line of sight parallel to a stick. You know, you could say that to show that it's straight. But yeah, then you cannot use the word straight for the word direction. You can say it's made out of a single piece if you understand the context. The context is you cannot chop direction in half. You cannot chop direction into pieces because direction is made of a single piece, so to speak. Okay? It's a concept that is made out of a single piece. Okay? And we call it line of direction. I think that's perhaps the best definition. And I leave it up to people out there to come up with better definitions. We broke our heads. We couldn't figure out any better than that. So that's all I can tell you right now, okay? Okay, but one fellow raised an issue, and it has to do with this word line, okay? Which has to do with direction as well, because we typically think, you know, it's a direction, or at least we replace it with a line to reify it, to put an object that we can see so that we can relate to the concept that it represents, right? That's the notion here. Okay, so here's my definition of line, which I've showed in the past. Line is equal to an object equal to a figure, okay? Because there you see a line. What is objectively in front of you? Well, you see an elongated rectangle. That's what you see there. And it's got two ends, one end here, one end there, okay? That's what a line is, okay? Now, it's just an elongated rectangle. You can see that it has four edges, okay? I showed three of them there. Okay, one on the top, the one with H, which is the height, and the one W, which is the width. And then at the other end, you have the fourth one. Okay, so it's got four edges. That's what you see in front of it. That's what's objectively in front of you. We're not talking about any subjectivity, any thoughts that you have going through your mind. We're just talking about what's there in front of your eyes. Okay, and it's straight. Okay, conceptually straight. It's continuous, made out of a single piece. Okay, in other words, it's not chopped. It's not segmented or made out of points, locations, numbers, or anything like that. It's made out of a single piece, okay? And it's finite. As you can see, it's finite. It begins here, ends there, top, bottom, same. Okay? It's got four edges, okay? The infinite line of geometry is not a figure because figure is that which has shape. It's a synonym of the word object. And the infinite line is simply also made out of points and it extends indefinitely, meaning you're talking about motion. You're talking about incessant motion, not about a physical object called line, which is what we have in front of us. Okay? And so they say, well, that's a line segment. But even the line segment is made out of points, meaning out of numbers, locations. They're talking about motion. They're talking about a bunch of apples in the best of cases, not about a stick. Okay? So again, the line of geometry is not a line, not a geometric figure. Okay, so what does this fellow say? Well, he says the following. He says, well, I say a two-dimensional line, and he says line is one-dimensional. Okay, and if you look up in the Wikipedia, it says line, a straight one-dimensional figure having no thickness. Okay, so I guess that's where he got this. He just copied and pasted. And a drawing of a line is 3D representation of a line. A line is a concept. And ask him why. You know, and this is what he comes up with. He says because it only resides in the minds of humans as an abstract idea. Okay, so he thinks that a line is a concept because it's only in the mind, not out there. Okay, and again, he's using subjectivity where I'm referring to the objective figure that he's got in front of us. Okay, the objective figure is a stick. That's what we have in front of us. And what he's talking about is what he's got in his mind, what he's interpreting. Okay, not objective but subjective again. Only 3D can be an object. All other dimensions are conceptual. And a fellow answers him, says, abstract ideas have no dimensions. An idea is not an object, and thus has no shape. And yeah, that's a pretty good answer, okay, for what this fellow proposed or copied. He just copied and pasted. Okay, so let's go through those key words. Why is a line a concept, okay? And he says because it resides in the mind. Where did he get this from? Well, here it is. It says, line, object with zero thickness and curvature that stretches to infinity. Line, an infinitely long object with no width, depth, or curvature. Lines are one-dimensional objects. And that's from the Wikipedia, so this is probably what he copied or where he got the idea, okay? And why is it a concept? Well, here it is. It says concept, an abstract idea. What is an idea? The result of thought. And it turns out that, idea is a synonym of concept, but aside from that, it says idea, mental representational image of an object. Okay, so we've got a lot of contradictions, you could say, or problems with these definitions because, if an idea is just a representation of an image or an image of an object, what are we saying there? Well, we're saying that that's just what an idea is. If I tell a story, that's not an idea. If I have a theory, that's not an idea. Only images are ideas. And again, if you look up the word idea, it's a synonym of concept. So concept and idea are synonyms. You can't use the word idea to define the word concept, or vice versa. Okay, so he fails with concept. Here we have the question of whether a line is a figure. Does it belong in geometry? And here it is. Figure, form, or shape as determined by outlines or exterior surfaces to be round, square, or cubical in figure. And so a one-dimensional whatever line, is that a figure? I mean, what's the shape? Because they're talking about form or shape. Okay. Geometry, a combination of geometric elements disposed in a particular form or shape. Again, is a line a shape? Does it have form? And all the examples they give, they don't put the point or the line, remember. They just put these circles and the squares and the cubes. Okay? And when you look at figure in Wikipedia, it says a shape, drawing, depiction of geometric configuration. What's a configuration? Well, there it is, a configuration in the plane. Okay, and what is it? A finite set of points or a finite arrangement of lines. Okay, so they use the word point to talk. Well, they use the word point, but they have not defined a point. But then they say a configuration is just a bunch of points and lines. Okay, so again, we still don't know what a figure is. Okay. And here's the point that they just mentioned. Point, a primitive notion that models an exact location in space and has no length, width, or thickness. So what kind of geometric figure is that? What is the shape of a point if it has no length, width, or height? Okay, which they call thickness. And it says it's a primitive notion. What is that? It's a concept that is not defined in terms of previously defined concepts. We learned a lot. Okay? In modern mathematics, a point refers more generally to an element of some set called a space. Okay, let's see what a space is. Okay, and we look up space. It says space is a set. What is a set? A collection of things. It contains elements or members. What is an element? It's a member of a set. And the set with an element, with no element, is the empty set. Okay, So I hope you learned a lot today with all this. You know, these are the definition of mathematics. Yeah, you can go on and on looking up all these words and they have no meaning whatsoever. And that's why they say, well, we cannot define what a point is. We cannot define what a line is. But they say it's a straight one-dimensional shape because it's got to be shape or form in order to qualify as a figure. And they say it's a figure. So you can see there is a contradiction there. And that's why they say we cannot define what a point or a line is. Okay? And just in case, you see they're one-dimensional. Okay, what's a one-dimensional space? Okay, in one-dimensional space, sequence of n numbers can specify a location in n-dimensional space. When n equal 1, the set of all such locations is called a one-dimensional space. An example of a one-dimensional space is the number line. Okay, so you can see that these people just run around in circles and you never get to the bottom of it. Is a line a one-dimensional space? What does it mean? Well, it means it's a set of all such locations. Okay, so you don't learn anything from mathematics definitions because they're all irrational. Every single one is irrational. They have never set the foundations of mathematics on a proper footing. Why? Because they use all these these qualitative words. And mathematics has nothing to do with quality. It has to do with quantity. So they're defining words that they're going to use eventually in geometry and by extension in physics. But all these words have nothing to do, or not one of them has anything to do with mathematics. Mathematics is about adding, subtracting, multiplying, dividing, powers, etc. Calculus. It's got nothing to do with qualitative stuff. And these are all qualitative words. So this is where the problem is. And so they never were able to define the qualitative stuff because they say, well, we're not English majors. We don't do that kind of stuff. That's where, people who work in libraries and so on, write books. That's not for us. We don't do that kind of work. All we do is calculations. And that's what they call science. Okay, so here we have a final issue on this, and that's the fact that, again, that's a summary of conclusion of what a line is. Yes, what you have in front of you is a line. Okay, not what this fellow said. What this fellow said, he reads more into what he sees. He says that's a one-dimensional line. No, it's not, because as you can see, it's got two dimensions, width and height. So it's not a one-dimensional line. But I challenge him to objectively, right? Scribble, draw, take a picture of, whatever, a one-dimensional line. And he won't be able to do so. Okay, so as you can see, this takes us to first the fact that the direction is a hard to define concept. We reify it with lines, and the line is straight, the line is continuous, but the line is reifying the concept direction. And that's where the problem is. We can do that easier with distance. Distance, you can reify it and say, well, it's distance, but you're not supposed to confuse the stick with the concept. Fine, no problem. We take the stick out and we say that's separation. What's that space between the two objects? But that's not as easy to do with direction. Direction, it's like you need to put that stick in there to illustrate it with an arrow at the end so you know which direction, but that only gives you a specific direction. It does not give you the definition in general of the word direction. The word direction, the best I can come up with is line of sight, and for that, you, the observer, have to look at the frame of the universal movie, put your eye in any location, any object, so you replace the object with your eye. That's what you're going to do subjectively, because again, we're talking about a concept. Okay, and concepts have to do with the observer. We created all concepts. So you put your eye, okay, you go through the motions of putting your eye at any location, any object you want, and you stare out. That's called line of sight, and that is what direction is, as far as we're concerned. Maybe you have a better definition.